Let f of x equal 2x squared plus 7x minus 3, and find its derivative function by evaluating the difference quotient. Find the value of the following and simplify each step. Okay, so first we need to find f of x plus h. So the difference quotient is, as in part 4, this formula here, and often the thing that gets students tripped up is just getting started in the problem. So we're going to take this step by step. So beginning with figuring out f of x plus h. Now to do that, I think I'll come down to the bottom here and work on this below because there's not much space above. So f of x plus h. What that means is wherever I see x within the equation, I'm going to replace that with x plus h. It's almost like the x in the equation is an empty box. Okay, and wherever I see that x, I can replace it with an empty box. And so whatever I put in the first empty box, it just automatically appears in the rest. So for instance, if I put x plus h here, it shows up here, it shows up here. So everywhere I had an x originally gets replaced with x plus h. Now, in addition, you want to make sure you put parentheses around each step. So 2 times in parentheses x plus h squared plus 7 times the quantity x plus h minus 3. And that's just to make sure that both items are multiplied by 7 in the second part, the whole binomial is squared in the first, and so forth. So let's work on that. Let's work on squaring this binomial x plus h. If I square that binomial, maybe I'll come up to the side. Anytime I have the sum of 2 items squared, the result, and you can show through FOIL, is a squared plus 2ab plus b squared. So this will become x squared, the first item squared, plus 2 times the first times the second, so 2xh, plus the second item squared. In the next part, I can distribute this 7 into these parentheses. So that would give me plus 7x plus 7h. Then I still have a minus 3. And lastly, I should go ahead and get rid of this first set of parentheses, but I'm going to have to distribute this 2 to all terms within. So this becomes 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 3. And that's everything that I can do at this point. There's no like terms to combine or anything to cancel, unfortunately. So that's the answer to the first part. So tell you what, instead of copying that over, I'm just going to put a star there, and so that's the answer to that part. So the next part is the difference between f of x plus h, what we just found. So we know that to be the 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 3. And then it's that minus f of x, which is the original function. So I would do minus the original function, which was 2x squared plus 7x minus 3. And one thing I do need to be careful of is these parentheses here and here aren't technically necessary, so I can really just drop those. There's no multipliers in front of those. But there is a negative in front of this set, and we need to make sure that negative distributes. So this becomes all of this again, 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 3, then minus 2x squared minus 7x and plus 3. So I have some things that will actually cancel now, which is great because this is getting to be a very long equation. So positive and negative 3 will cancel. Negative 7x and positive 7x will cancel. Negative 2x squared and positive 2x squared will cancel. So all that remains at this point is just 4xh plus 2h squared plus 7h, and I think that's it. Yeah. So that's going to be the answer to part 2. Now I know everything's getting a little cramped on screen here, but for part 3, I'll just put a little line here for part 3. I'm going to take that result and divide it by h. So effectively, what happens is, if you'll notice in all of these items, I'll tell you what, let's leave that away. In all of these terms, there is a factor of h. And therefore, h is a common factor of all those values. So that leaves me with h times 4x plus 2h plus 7. Now, in step 3, what they want me to do is to take that result and divide it by h. So there's this h in the numerator and the denominator which cancel, and therefore I'm just left with 4x plus 2h plus 7. So that's the answer to part 3. Part 4, all I have to do now is to take this limit. So it's the limit as h goes to 0 of what we have from part 3, which is 4x plus 2h plus 7. And if I let h go to 0, the only thing that happens is this term right here would go to 0, leaving me with 4x plus 7. So the result here is a function, but that's okay. That just means that the slope of these tangent lines for this particular graph is changing at all points along the graph. And so this gives me a function that represents all the slopes of all of those tangent lines. So this is perfectly fine to answer as a function.